The distance s that an object falls is directly proportional to the square of the time t of the fall. If an object falls 16 feet in 1 second, how far will it fall in 3 seconds? And then once we've answered that question, we're asked how long will it take for the object to fall 64 feet? To begin, we're going to write a variation equation that describes this first phrase, that the distance s is directly proportional to the square of the time t. That phrase is going to translate into a math equation where s is in direct relationship with the square of the time t. So that means that the square of the time is going to be multiplied by our variation constant, which we're using k to represent. So this is what we're going to refer to as our template variation equation that describes the relationship between s and t. But the first thing that we want to do is use the given initial conditions to find the value of k. So going back into the given information, we see this phrase here that says that an object falls 16 feet in 1 second. So this is the initial condition that can be used to find the value of k. So we're going to plug in 16 for the distance that the object has fallen. K is the constant of proportionality that we're trying to solve for. And we know that it took 1 second for the object to fall 16 feet, so we plug 1 in for t, and then solve for k. So what we end up with here is k times 1, or just k on the right-hand side. So our variation constant is just 16. Now this value of k is then plugged back into that original template equation, and that enables us to improve our description of how distance and time are related. So we'll say that the distance that an object falls is going to be in direct relationship to the square of the time that it falls, but now we know that that's by a factor of 16. So let's refer to this as our updated variation equation. And this is now what we're going to use in order to answer any remaining questions. So back up here in the word problem, we see that we were asked how far will this object travel in 3 seconds. So because we're asked how far, that's our unknown quantity. The distance is what we're being asked to find, but we're told that the object falls for 3 seconds, so we're going to plug in 3 for the amount of time. Now we have 16 times 9, which is 144, and since our initial condition distance was measured in feet, those are going to be our units. Now we have a secondary question that says how long will it take for our object to fall 64 feet, but we are going to again use the updated variation equation in order to answer this question. So here we're being asked how long it's going to take, so we're going to be solving for t, and we're given the distance that it fell, so we'll plug 64 in for s. So 64 gets plugged in for s, and we are asked to find the amount of time. So we're solving for t. Let's divide both sides by 16. The 16s cancel out, and we end up with 4 on the left-hand side is equal to t squared. To solve for t, we're going to take the square root of both sides, and anytime we take the square root, we have to consider the plus or minus. But because the value of t is equal to time, we're only interested in the positive values. So the square root of t squared is just t, and the square root of 4 is 2. And since the initial conditions were measuring time in seconds, we use the same units for our answer.